What's going on, my Math 8 people? We got lesson 8-2. This is when it gets good. Solving systems by graphing. All right, so what is a system? So a system of equation is when you have not just one equation, but sometimes multiple equations, and you want to know where do those equations have the same answer. Okay, so you've got more than one equation, and you want to see when they have the same answer. So let's look at a couple things here. We've got the equation y equals 2x minus 1. How many answers does that one have? Well, you can put in a number for x, like 1. 2 times 1 is 2. 2 minus 1 is 1. And there's an answer. I plugged in 1, I got 1. I could plug in 0. 2 times 0 is 0. 0 minus 1 is negative 1. I got a second answer. I can keep on plugging in answers for x and getting new answers for y. Those are solutions. Solutions are ordered pairs, x's and y's. So how many solutions are there? There are an infinite number of solutions. What about this other equation? Well, it's the same deal. I can keep on plugging in numbers for x and getting new numbers for y. I could do it until the rest of my days. So this one also has an infinite number of solutions to it. An infinite number of ordered pairs, x's and y's, that work in these equations. That's what a solution is. So both of them have an infinite number of solutions. But how many solutions do they both have? Do they share? Let's go ahead and graph them and see, because remember, a graph is just a listing of all the solutions that work. So let's go ahead and graph this using y equals mx plus b. My slope is 2, or 2 over 1. My y-intercept is negative 1. All right, so negative 1, that's 0, negative 1 right here. The slope says go up 2 and right 1. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Now we can also make this negative 2 and negative 1, because if they're both negative, it's a positive. So we can go backwards. Down to left 1, down to left 1. They're all on the same line. All of these points here that I've made are solutions. They work when you plug in the x and get the y. So this line represents all of the solutions that could work for y equals negative 2x minus 1. Those are all my solutions. That's what the line represents. So 0, negative 1, that's a solution. 1, 1, that's a solution. 2, 3, that's a solution. They all work when we plug it in here. Okay, so those are the infinite number of solutions for that equation right there. Let's do the other one. Y equals 1/2 x minus 4. The slope is 1 over 2. The y-intercept is negative 4. So we start with our y-intercept. We go down 4. And this says go up 2 and right. Sorry, go up 1 and right 2. So up 1, right 2, up 1, right 2, up 1, right 2. I can also go backwards. I can go down 1 and left 2. Down 1, left 2. Down 1, left 2. So this pink line represents all of the possible solutions that would work for the second equation. So the blue line, first equation, those are all the possible solutions that work, the infinite number of solutions. Pink line, second equation, those are all the infinite number of solutions that would work there. So how many solutions do both of the equations share? They only share one solution. They both have an infinite number of solutions, but there's only one solution that works for both of those equations. And the solution is negative 2, negative 5. They share one solution, -2, -5. That is the only solution that works for both equations. So the solution to a system of linear equations, that's my solution, will be the blank blank where the lines intersect. It'll be the ordered pair. So our answer will always be a coordinate. We're looking for where they cross. Now it says show mathematically the solution of the system is a solution for both equations. Okay, so let's look at my first equation. That was y equals 2x minus 1. The solution says x is -2 and y is -5. So instead of y, let's plug in -5. Instead of x, let's plug in -2. So I get -5 equals 2 times -2 is -4. And then -4 minus 1 is -5. All right, so -5 equals -5. Yeah, that makes sense. So that means it is a solution. So we've proven that our answer was a solution for the first equation. Let's prove it's a solution for the second equation. Y equals 1/2 x minus 4. So let's plug in -5 for y and -2 for x and see if it's a solution. So you do -5, 1/2, -2, minus 4. All right, so -5 equals 1/2 times -2. That just means -2 divided by 2, because you can multiply by 1, then divide by 2. So -2 divided by 2 is -1. -1 minus 4, yep, that's -5. We've proven that it is a solution for both equations. Now, looking at the graph, that's the only point that works for both equations. All the pink line works for the second equation. All the blue line works for the first equation. There's only one point that works for both equations. And that's what a system is. We're looking for that one point that works for both of the equations. And we found it. It's right there. -2, -5 would be my solution. All right, let's practice it. So if you're at home trying to stop for the first time, just go ahead and try to graph these, and remember your solution is the ordered pair or the two lines cross. So you can kind of pause right now, try it out on your own, see how you do, and you can come back and check my work. All right, I'm going to go a little bit fast through this. So my slope is -2/1. My y-intercept is 5. So I go up 5, and then I go down 2/1, down 2/1, down 2/1, down 2/1, down 2/1. There's my first line. Those are all the solutions that work for the first equation. Second equation, the slope is 1/3. And the y-intercept is -2. So I start by going down 2, and I go up 1/3. There it is, up 1/1, 2, 3. I can go down 1 backwards 3, down 1 backwards 3. Okay, so these are all the solutions that work for the second one. There was only one solution that worked for both of them. That point right there, that's the point 3, -1. So my answer to the system is 3, -1. That is where they intersect. It's the only point that works for both equations. Next one, slope is 1/2. Y-intercept, I don't see a number over here, so the y-intercept is 0. So this one goes through the origin. We're going to go up 1/2, up 1/2, up 1/2. Or we can go down 1 backwards 2 if we're feeling saucy. Delicious. There we go. Okay, those are all the equations, all the ordered pairs that work for that first equation. Second one has a slope of 3/2, y-intercept of 2. So it goes through 2, That's the y-intercept. And then it goes up 1, 2, 3, backwards 2. Well, that's going away from the intersection. It should go back here. So let's go down 3 and backwards 2, or left 2. 1, 2, 3, back 2. Ah, there's an intersection. Down 1, 2, 3, back 2. All right. There's our second line. Those are all of the solutions that work for the second equation. There is only one solution that works for both, and that solution is -2, -1. So our answer is -2, -1. It's where the lines cross because that is the one solution that works for both equations. Second one, or third one. Slope is 3/4. Y-intercept is -4. Second one, slope is -3/2. Y-intercept was 5. I'm going to grab the first one. Y-intercept was -4, so I go down 4. And then we're going to go up 3, right 4. 1, 2, 3, right 4. And that's all that's going to fit on this graph. So let's go ahead and grab it. There's the first equation. Second equation. Got y-intercept of 5. This is going to go down 3 and right 2. Down 1, 2, 3, right 2. Down 1, 2, 3, and right 2. Ah, there we go. Down 1, 2, 3, and right 2. All right, we have our answer. There's the second line. We can see that they do have an intersection point. The intersection point would be at 4, -1. And that is our solution to the system because that's the one solution that they both share. Now, Melanie claims that -2, 5 is a solution to this system, y equals 4x plus 13, and y equals -2x plus 9. How can we check to see if she's correct without graphing the two lines? This would be a pain to graph because our graph would have to be pretty big to get a y-intercept of 13 or a y-intercept of 9. But Melanie's done the work for us, and she thinks she has an answer. She thinks the answer is -2, 5. Well, how could I check without graphing? Well, I can check to see if this is a solution for both of them. If it's a solution for both equations, it's a solution for the system. So we're going to test -2, 5 in both those equations. So we've got 5. I'm plugging in for y, 5 for y, and -2 for x. So I'm testing the first equation. I get 5 equals -8 plus 13. And -8 plus 13 is 5. So this is a solution for this equation. This point is on this line. That's what we've proven right here, because it's a solution of that one. But it's only a solution to the system if it works for the second point, or the second line as well. So we have to test both of them. So let's plug in 5 for y. And then -2, instead of x, we plug in -2. We get 5 equals 4 plus 9. And 4 plus 9 is, 13. That is not a solution for that one. So this point is not on this line. It's on this one, but not on this one. So that would be like this point here. This point here is a solution for this line, but it's not a solution for this line. So it's only a solution for one line, and our solutions have to be solutions for both. And so since it's not a solution for both, Melanie was incorrect. It was only a solution for the first equation, not both. Oh, I told you that was going to be good stuff. All right, that's all I got for you today. I will see you next time. Bye-bye.